Today I'm joined by Darragh Magee of AEG. And as you know from my previous videos, covering slurry and digestate stores is a target for DEFRA to reduce emissions from ammonia, with a UK deadline of 2027 for all stores to be covered. So Darragh has very kindly joined me today to help me answer some questions that farmers and anaerobic digestion site operators often ask me about impermeable floating covers for lagoons and also for above ground storage tanks. So Darragh, you supply a range of floating covers. What are yours made of?
Well, the conventional floating cover, the material we use is Genitex 900 1mm thick PVC.
Okay.
It's a woven reinforced sheet. It needs to be very strong, but it needs to be flexible, and it needs to have a high UV light tolerance. There will be water lying on the surface of any floating cover, and that will magnify the effect of UV light if you're using the wrong material. If you do use the wrong material, after about 4 or 5 years, it will start to change color and go brittle. And obviously it's important on a floating cover that you don't have brittle material, because it does need to be able to ripple in the wind without cracking.
Okay. I guess that effect with the wind might be slightly less if you have a circular tank where the cover will be inside, compared to the lagoon, which I guess has a very, very big surface.
That is true, yes.
Yeah,
definitely. I mean, on a circular tank, the design is quite different, because you haven't got surplus material when the tank is full. A lot of people think that covering lagoons, you actually stretch a sheet across the top of the surface, and that is not how it works. You use exactly the same amount of material as if you're lining a lagoon, so that when you have a full lagoon, the floating cover is floating on the surface, and as you empty the lagoon, it's got to be able to drop all the way down to the bottom. So if you've got a full lagoon, that surplus material is there, and if you have a non-flexible material, it will get damaged by the wind.
Yeah, well, that makes sense. So a lot of farmers have clay lagoons and others have the lined lagoons. Are there any differences when you're installing one of these floating covers and these different lagoon types?
Yes, there are. We use exactly the same technique to install to both a lined or a clay lagoon. And that is that you have got to dig a key trench round the outside banking of the lagoon, and that key trench acts as an anchorage point. You put the outer edge of your floating cover into the key trench and backfill it to hold the whole thing in place. Now, on a lined lagoon, normally the condition of the banks are good, and you're dealing with a perfectly consistent bank surface. With the majority of unlined lagoons, they have been eroded over the years and are normally quite unstable. So it is absolutely essential that before you put a floating cover on, that you carry out repair work, stabilize the whole thing up. Because apart from anything else, when you're mixing under a cover, if it's a unlined lagoon, that erosion will continue to take place under the cover in the future. So it's very important that they get their maintenance done before they put a floating cover on.
Yeah, I guess that's easier if it's a newly dug clay lagoon, and then I guess you're starting from a good surface to begin with.
Yeah, obviously.
Yeah. Great. Okay, so we've talked about the cover, and now a lot of people say, okay, so when the cover's on, how do you get the slurry or the digestate in and out of the store?
Okay. A floating cover on a lagoon, the best way to do it is to pipe it in and out. It's important that you run the inlet and the outlet pipes right to the bottom of your lagoon. It's exactly the same as most lagoons have anyway. Most lagoons are emptied and filled through pipework. On the outlet pipe, you need a double valve system to meet the regulations and a bower coupling. And what we do is we seal the floating cover to that pipework. So it maintains the integrity of the floating cover. Filling and emptying with the floating cover should not be a problem in reality.
So you've got your cover on, and then of course, generally farmers are mixing the slurry or digestate before they remove it from the store to ensure it's got a good consistency for spreading. So a lot of farmers ask me, so you've got this cover on, how do you actually mix once the cover's on?
Okay. If you're installing a new lagoon from scratch, the most practical thing to do is to install a jetting mixing system into the lagoon. So basically, it's a series of pipe work on the base of the lagoon with jets. And you utilize your umbilical spreading pump to, put simply, suck slurry out and then blast it back in, so that you can get a circular current going at the base of the lagoon to keep the dry matter that's settled there moving and get it back into suspension. We can retrofit jetting systems as well to an existing lagoon, but it's a lot easier on a lined lagoon than an unlined lagoon for fairly obvious reasons if you think about it.
Yes.
You can still use the normal PTO-driven propeller mixers, providing that you guard the mixers so that the propellers don't come into contact with anything. And there, what we do, we install what we call a goalpost system. So it looks exactly like a goalpost, again with pulleys, so that you can raise the floating cover, reverse your PTO-driven shaft under the cover and just work away. Most people anyway should already have installed mixing points even in uncovered lagoons, where they have a concrete pad on the base and a barrier system on the top of the bank, so that the tractor is always reversing to exactly the same spot.
Yeah.
With a barrier to prevent it from falling in. And then when they lower their PTO mixer, it is always hitting the concrete pad below.
Yeah.
So we just build a goalpost system over the top of that.
Okay, great. And so you've already mentioned that there might be some gases when you lift the cover up in that scenario where we were talking about if you have a ramp for scraping the slurry in. So will gas build up in the cover, under the cover, is a common question that I'm asked.
Yes, I mean, your cover is going to reduce the amount of gas released from the slurry or digestate, hopefully by about 80%. Right? So you're still going to have a fair amount of gas building up underneath the cover. And if you just had an unvented cover over your lagoon, you would end up with a balloon effect.
Okay.
If you think about it. That's quite dangerous from 2 points of view. First of all, from the point of view of the cover itself, it then becomes very exposed to wind damage.
Yeah.
But also, you've got, if you think about it, you've got hydrogen sulfide and methane, as well as the ammonia accumulating under the cover. And everybody knows the dangers of hydrogen sulfide in particular. So when you're installing a floating cover, and we install the vast majority of our floating covers in one piece, so they are prefabricated to actually fit your lagoon, as opposed to welding up strips on site. So we install floaters into that cover, and they have two jobs. One, to literally help the floating cover float on the surface, to stop it funneling down when it fills with water. But secondly, those floaters have venting pipes in them to vent gases off when the pressure under the cover gets to the point that it needs releasing. Also, we put ventilation pipes all the way around the crown of the bank of your lagoon, because as you're emptying your lagoon and your floating cover is dropping towards the floor, the gases will then go under the cover up the banking and they need to be released. So we put a venting pipe all the way around with a series of chimneys to release the gases to atmosphere.
Okay, that makes sense.
Yeah, and that I think is very important. I have seen floating covers where people have put them on and there is no venting facility at all. And it just seems to me completely crazy to take that approach. Okay, you might save yourself a few pounds, but you're going to cause yourself a lot of trouble in the long run.
Yeah. But obviously putting the cover on reduces the ammonia emissions, like you said, by quite a high percentage. I think 60 to 80%, isn't it, depending on the cover type? Yeah. Great. So you've already mentioned that obviously when it rains, you've got a lagoon with a very large surface. So fresh water will obviously land as rainwater on the cover. So how is that removed?
Okay. Well, first of all, you do need some rainwater on the floating cover to act as ballast. And it's very simple that you can just use a simple, normally very cheap pump to pump water off the top of a floating cover. But you do need to leave some behind. More and more people now are actually harvesting that water to utilize it. On farms, I know quite a few people that are harvesting it and they're using it for flushing down.
Yeah.
On AD plants, they're utilizing it in the soup you into the plant. Because, I know one of our customers in the northeast of England, about 2 years ago, he had 5 fairly large lagoons, and he reckoned that the water intake between the 5 lagoons winter before last came to about 16,000 cubic meters.
Wow.
That's a vast amount of lost storage.
Yes.
But it's also a vast amount of unnecessary expenditure in spreading it.
Exactly, yeah. I mean, that's the other benefit of these impermeable floating covers, that you do reduce the volume of the slurry or digestate. So that's a really good reason for considering them.
Yes.
Great. So the last question that some farmers ask me is, it's a plastic cover. We've talked about the degradability depending on the cover type, but sort of the covers, how long do they last?
You should have a minimum design life of 20 years.
Okay, so that's something for people to look out for. That's very helpful.
Yeah. That is a regulatory requirement, and certainly if you're hopefully getting a grant on the floating cover, they will require a minimum design life of 20 years, I would imagine. How long they last? Well, they should last more than 20 years. I think it's important to bear in mind that you've got to have the right material because of the effect of the UV light more than anything else. And if you haven't got the right material, I have seen people using the wrong material and they run into trouble within 4 or 5 years.
Really? That's quite a short time, isn't it?
Yeah, goes brittle. If your material starts to lighten in color, you will then see it starts to go brittle. And then with the movement from the wind and the movement up and down in the lagoon, you will develop cracks.
Okay, great. Well, that's been really helpful insight into the floating covers for slurry and digestate stores. So check out my other videos on way to reduce ammonia emissions from storage and other ways in agriculture. Thank you.